Alrighty, here's the last part. We are going to start making the connection between those sequence of numbers that we've been looking at with and finding the pattern with building a formula that describes the pattern. And the way we're going to do that is by using expressions as formulas, and the n values are going to represent the position or the term values, right? So remember, in all the examples that we did, there was always the first term, the second, the third, the fourth, and so on. So my n value is going to stand for the what position term we're talking about. So if you look at n1, this is the first term. N2, this is the second term. So they're still in order, right? But now I'm going to use this formula to figure out the exact number that should go in that position, in that place. So here's the way you do it. Take the formula. You know the number that you're going to plug in, so let's plug it in. So 8 times your position number plus 3. Since this is the first term, we're going to plug in 1. And we're going to get an answer out of that. What's 8 times 1 plus 3? You can do that in your head. You can do it in your calculator, wherever you want to do it. But 8 times 1 plus 3 is still going to be 11. That's the first term. To find the second term, we're going to take the formula and we're going to substitute a 2 in there because we're looking for the second term. So 8 times 2 plus 3, whatever that is, that's going to be the second term. So 8 times 2, that's 16, plus 3, that's 19. There's the second term. And then I get to the third term. So 8 times the position number. The position number is 3 because this is the third term. 8 times 3 is 24, plus 3 is 27. Or you can use your calculator. You don't have to do it in your head. And then the last part, 8 times my position number plus 3. I'm looking for the fourth term. So my position number is 4, and it equals 4. And then figure that out that way. And I believe that's going to be 8 times 4 is 32, plus 3, that's 35. This is my sequence of numbers, 11, 19, 27, 35. Is there a pattern? Is there a pattern to go from 11 to 19, 19 to 27, 27 to 35? They're getting bigger, so I'm either adding or multiplying by a whole number, and I think I'm adding 8 every time. So if I'm adding 8 every time, that means this is an arithmetic sequence. An arithmetic sequence produces a list of values in order that are increasing by the same number every time. That's it. Can you do number 15? Number 15. The formula says take the position number. So in our case, that would be 1. Let me use green since I used it here. 1 times the position number plus 1. So the position number plus 1. And divide everything by 2. So you're taking whatever the position number is. So n equals 1 because it's the first term. And then you're going to multiply by 1 more than that. And then divide it by 2. So really, this is 1 times 2 divided by 2. And I believe that's just 1. You can plop it into the calculator and you can figure that out. That's fine. All right, let's do the next one. Using the same formula here. My position number, which is 2, times 2 plus 1. And then divide everything by 2. That's what the formula says, right? Position number times position number plus 1. So 2 times 2 plus 1 divided by 2. And I believe that's going to be 2 times 3 divided by 2. And that answer is 3. My second term in this sequence is 3. So some people like this because we're just using a formula to figure things out, right? We're just plugging in the number and that's giving it out to us. So let's do it one more time. And then I want to show you what you could do. Actually, let's finish this. And then I'll show you what you could do. So this is the third term, so I'm going to use n3. N equals 3 times 3 plus 1 divided by 2. And if you do all of this business, that's 3 times 4 divided by 2. And I believe that is 6. This looks familiar. And then I'm going to do one more. Let's do this one where I'm substituting 4 because it's the fourth term. And so that's going to be 4 times 5 divided by 2. And I believe that's 10. Wait a minute. Where have I seen these numbers before? 1, 3, 6, 10. Hmm. 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 1, 3, 6, 10. Oh, it's the triangular numbers that we did with number 10. So what we just found is that this formula will create each of those terms individually. All you have to do is plug in the position number. If I wanted the fifth term, I would plug in a 5. If I wanted the 10th term, I would plug in a 10, and I can figure it out. By the way, am I adding the same number every time? No. And so therefore, this would be an other. So at this point, I do want to show you something because this is how it works. But in reality, we have a calculator, and the calculator can probably do things a little bit faster. And so I'm going to go to my calculator. And I'm not going to go here to the main screen, even though I am on the main screen. I'm going to go to mode. Because if you look at mode and you go down to the fifth line, right now we're in function mode, but we can put things in sequence mode. And we're talking about sequences. We're talking about lists of ordered terms. And so when I press enter and I go to y equals, it changes things. Now this looks different. That's okay. So what we're going to do is we're going to type in the formula that they gave us for number 16, n over n plus 1. And so I'm going to type it in as a fraction. And I'm going to use the variable button that's in red right now. Usually I press it and there's an X, but look what happens when I press that button that's in red. I get an n over n plus 1. When I change the mode, it changed the variable, which is why that button has 4 different variables, x, t, theta, n, because those are the 4 different modes that the calculator could be in. I think that's what I need. Let me see if it gives it to me. I'm going to go to the table, second graph, and it does. It gives it to me. So the first term is 1/2. The second term is 2/3. The third term is 3/4. The fourth term is 4/5. Oh, I can get the answers a lot quicker by letting the calculator do the work for me. Now, as I write them down, I do want you to notice there's a pattern with the fraction numbers, right? With the numerator and denominator. Do you notice how the top is just 1, 2, 3, 4? But the bottom is one more than whatever the top is. It's one more than whatever the top is. So the bottom is always one more. So if I wanted to get to the fifth term, that would be 5 over 6. The sixth term, 6 over 7. The 20th term, 20 over 21. Is this a pattern where I'm adding the same number over and over again? No. Is it a pattern where I'm multiplying by the same number over and again? No. So this is one of those other types of sequences. So what I would like for you to do is to do number 14 and 13. Now that I've shown you how to do this on your calculator, you can do it that way. You can do it the old school way like we did number 13 and 15. It's up to you. But I need you to go ahead and try yourself 14 and 17. And then if you want to try 18 through 20, just for fun, see if you can figure out the next 3 terms in the pattern, you can. These are not arithmetic or geometric, or they're just different types of patterns. And just for fun, see if you can figure out how you got the next 3, or explain how you got the next 3 terms. So far, I'm asking you to do 14 and 17. In the previous video, I had asked you to do number 12. And then previous to that, I had asked you to do 5, 6, 7, and 8. If you would, with your partners, work these out, check yourself, and then drop it in the folder. And then we'll pick up where you left off on next week. That is our goal. I am going to activate a Khan Academy. So check your Khan Academy to see what's there for you to do. But if you understand this pattern finding that we're doing, the Khan Academy is going to be pretty straightforward.